Hey Biology 400 people, this is Mr. Gales, and today I'm going to spend a little bit of time going over the review activity called Identifying Chemical Compounds. This is on pages 93 through 95 in your organic chemistry packet. Also, I'm going to be referring to the coloring worksheet, coloring plates. So that would be page 54 for carbohydrates, page 62 for lipids, page 72 for proteins, and page 82 for the nucleic acids. So you may want to have those out as we're going through this activity. All right, we did this in class. The directions were pretty simple. You're supposed to use whatever resources necessary to help you review these organic compounds. On the first line, we're going to write whether the formula is molecular or structural. Big difference there. Structural is the kind of formula that shows the arrangement of the atoms. If it is a structural formula, we need to put a circle around any carboxyl groups and a box around any amino groups in that formula. And then on the second line, under each formula, we want to list the elements present in that substance. On the third line, we're going to indicate whether the substance is organic or inorganic. And then finally, on the last line, we want to indicate the category of organic compound, such as carbohydrate, lipid, protein, or nucleic acid. But then we also want to be as specific as possible. On your exam, the more specific you are with your description of the molecule, the more points you'll earn on each of those questions. So if it's a carbohydrate, you're going to want to tell me, is it a monosaccharide, a disaccharide, or a polysaccharide, for instance? Or if it were a lipid, is it a fatty acid? If so, is it saturated or unsaturated? Okay, so let's go ahead and go through this. For number one, the first thing we're going to do is identify whether it's molecular or structural. And when I look at this, this shows the arrangement of the atoms that are present here. So I'm going to call this a structural formula. Okay. And there's, again, the instructions are going to ask you to put a circle around carboxyl groups and put a box around amino groups. And there are no carboxyl groups here. There is an amino group that's up here that is attached to this ring-shaped structure up at the top. Okay, the next thing we need to do is write down the elements that are present in this substance. So I see carbon, and I see some hydrogen and oxygen. Obviously there's nitrogen from that amino group, and I also see phosphorus over here. So I have 5 out of the 6 major elements that are found in organic molecules. On the third line, we're going to indicate whether it's organic or inorganic. This molecule is organic because it's built on a hydrocarbon backbone that's carbon and hydrogen together, and it also has oxygen, nitrogen, and phosphorus. So this is a great example of an organic molecule. Now, the next thing that we need to do for this particular item is identify what class of molecule it belongs to and then be as specific as we can with it. So if I'm going to think about this, I need to, first of all, look at the atoms that are involved. This has got carbon, hydrogen, oxygen, nitrogen, and phosphorus. So thinking back to the notes that you took from the screencast, each of those screencasts should have highlighted for you the elements that are present in each type of organic molecule. Carbohydrates and lipids are limited to only carbon, hydrogen, and oxygen. So that would be one way to eliminate those as possibilities. Proteins contain carbon, hydrogen, oxygen, nitrogen, like this one does, but this molecule contains phosphorus. Those are not found in proteins. Those are found in nucleic acids. So simply based on the elements that are present, that would be one way to identify that this is a nucleic acid. The other way would be to recognize that this structure has a phosphate group on it. It's got a 5-carbon ring structure here, which is kind of like a sugar, and then this one is a nitrogen-containing ring. So that's a key idea related to the nucleic acids. So I'm going to write this one down as a nucleic acid. Okay. And then to help me to write as specifically as possible about this particular molecule, I'm going to find the nucleic acids page. That's page 82 in your packet, and have that to look at as I'm trying to figure out what kind of molecule this is. So when I look at this picture, I'm seeing that it is kind of like this, right? It's got a phosphate group, it's got this 5-carbon ring structure here, and it's got this nitrogen-containing group. So I'm going to look and I'm going to see that that is called a nucleotide. That's the building block of a nucleic acid. So it's nucleic acid and it's a nucleotide. Okay. The other thing we're going to take a look at, sorry, my laptop just went to sleep there momentarily. The next thing we're going to take a look at with this particular molecule is, does it relate to DNA or RNA? And the way that you can always tell that with nucleic acids and nucleotides is number the carbon atoms. This is carbon 1, 2, 3, 4, and 5 up here. When you're looking at a nucleotide, what you want to do is isolate carbon number 2 and identify what kind of atom is attached. If you have just a hydrogen atom, then you're looking at deoxyribose. If you see a hydroxyl group present there, then you know you're looking at the ribose. So this is deoxyribose sugar, which is present in DNA. So this is a DNA nucleotide. And we can even become more specific because we can look at the type of nitrogenous base that's attached. And up here at the top, we see a single ring structure. The single ring structures for nucleotides would include the pyrimidines. So that makes my answer as complete as it possibly can be. Okay, so for number 1, we have a nucleic acid, and it's a DNA pyrimidine nucleotide. Okay, number 2. This is a molecular formula. It does not show the arrangement of the atoms. It just simply shows the type and number of atoms. The elements that are present are carbon, hydrogen, and oxygen. It's organic because remember, to be organic, it has to have carbon, and organic molecules are built on hydrocarbon backbones. That's carbon and hydrogen together. So this is definitely organic. Now, what type of molecule is it? Well, it's carbon, hydrogen, and oxygen. Those 3 alone. So the only 2 types of molecules that are just those 3 atoms are either carbohydrates or lipids. So to tell the difference between those 2, we need to think about something that distinguishes them. One thing that distinguishes a carbohydrate is that the atoms appear in a 1 to 2 to 1 ratio. So if there are 12 carbons in this total group, 12 carbons, that would be, if it was a 1 to 2 to 1 ratio, would see C12, H24, and O12. It's a little bit different from the ratio that we see up at the top. So how different is it? Well, we've lost 2 hydrogens and 1 oxygen here in this formula that we're given. 2 hydrogens and an oxygen, if we put those together, that basically is water that's been lost, and we can surmise that this has been lost through dehydration synthesis. So I'm guessing that this is a carbohydrate and that it is actually a disaccharide because there are 2 single units that have been joined through a single dehydration synthesis reaction. So I would call this then disaccharide. Now, you may not be able to get more specific than that. You can't tell the difference between disaccharides simply by their chemical or molecular formula. Remember, there are structural differences, isomers in those different molecules. So number 2 is now complete. Number 3, this is a structural formula. It contains carbon, hydrogen, oxygen, and nitrogen. Now, this group up here at the top is the R group. That alone should be one clue as to what kind of atom this is. That doesn't mean an element, that's the R group. The next thing we're going to look at is whether it's organic or not. This is, of course, organic because it contains carbon and hydrogen with oxygen and nitrogen. So that takes us down to the last line, number 4. This is going to be associated with protein. And the way we know that is it contains carbon, hydrogen, oxygen, and nitrogen. That's one way. The other thing is the proteins were the types that contain these R groups. So protein is the general class that this belongs to. And then we can become more specific by describing what this actually is. This is a single building block unit. This is going to contain an amino group. Remember, we're supposed to put a box around amino groups, and it contains a carboxyl group. We're supposed to circle those. So amino and carboxyl. This is actually an amino acid. Okay. We don't know what kind of an amino acid is. We can't tell whether it's polar or nonpolar because the R group's not defined, but we do know that it's an amino acid. All right, next one is NaCl. That's sodium chloride. This is a molecular formula. It's got sodium and chlorine, and it is inorganic. So we don't need to go any further than that. We move on here. The next one is CH4. This is a molecular formula. Okay. We have the elements that are present are obviously carbon and hydrogen. This is organic. This is the simplest type of organic molecule. This is what we call a hydrocarbon. So I would simply write down here, this doesn't belong to any of the major groups of organic molecules, but it's called a hydrocarbon. It's what we build our hydrocarbon backbone for the organic molecules with. This specifically is methane, CH4. All right, moving along. Here we have a structural formula. There are no carboxyl groups or amino groups that are present here, but we do see that there are several or 3 hydroxyl groups present. When we have carbon-based structures that simply have hydroxyl groups on them, one clue is that that is an alcohol, an organic alcohol. So that would be something for us to look at. This contains carbon, hydrogen, and oxygen. Okay, it's organic. And then when we think about what kinds of molecule that it could possibly be, we have the choices now. Carbon, hydrogen, and oxygen is going to be found again in either the proteins or the carbohydrates. So we need to look at it. Does it look like a carbohydrate? Does it look like it could be associated with lipids? So now we're looking on pages 54 and page 62 for this information. One thing, remember, that we noticed was carbohydrates have to have a 1 to 2 to 1 ratio for monosaccharides. Here we have 3 carbons, we have a total of 8 hydrogens, and we have 3 oxygens. So it's not a 1 to 2 to 1 ratio. So that probably is going to rule out it being a monosaccharide. So let's look at the lipids. What could it possibly be if we look at the lipids? Well, 3 carbons with hydrogen and hydroxyls. We see this here. Now, this doesn't have the hydroxyl groups, but what this is showing us is that the hydroxyl groups are probably been lost to dehydration synthesis, and here we have a bond that joins the building blocks together. So this molecule is actually related to lipids, and specifically it is glycerol. And that's a building block of both triglycerides and the phospholipids. Okay. Next one we're going to look at, this is also structural. And here we're going to put a circle around this group here. This is a carboxyl group. The elements involved, carbon, hydrogen, and oxygen. There are, in this case, this is an organic molecule. And again, I have 2 central choices. If I've got carbon, hydrogen, and oxygen, I know that's either a carbohydrate or a lipid. And if I look at this, this is clearly not in a 1 to 2 to 1 ratio because there's very little oxygen present here. What we have is lots of carbon atoms, lots of hydrogen atoms, but very few oxygens. So I'm going to classify this one as being a lipid. And then specifically when I look at this, and I can use my sheet here as a clue, this is going to be a lipid. And if I look at the structure, lots of carbon with hydrogen, that's going to be one of these here. So what do we need to find out what that is? That's a fatty acid. So I can say lipid, fatty acid. Okay. And then specifically, this is a saturated fatty acid because these are all single bonds that are present. In unsaturated fatty acids, you would have 1 or more double bonds between the carbons. All right, the next one we're going to take a look at, this is magnesium hydroxide. This is a molecular formula. The elements here are magnesium, oxygen, and hydrogen. It's inorganic. Okay, and so we can stop on that one. Here, this is a structural formula. We do not have any carboxyl or amino groups here. There are hydroxyl groups present, but no amino or carboxyl groups. The elements, carbon, hydrogen, and oxygen. It's organic, again, because it's based on carbon and hydrogen, a hydrocarbon base with oxygen in it. So what kind of molecule is it? Well, again, carbon, hydrogen, oxygen, it's either going to be a carbohydrate or a lipid. So easiest thing to do would be to try to identify that 1 to 2 to 1 ratio. Let's count them up. I've got 1, 2, 3, 4, 5, 6 carbons. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And then the oxygens would be 1, 2, 3, 4, 5, 6. So that's 1 to 2 to 1. That's telling me this is going to be a carbohydrate. And because it's a pure 1 to 2 to 1 ratio, this is going to be the simplest kind of sugar. This is going to be a monosaccharide. All right, now you don't know for for sure what kind of monosaccharide it is. Remember that there are different kinds of monosaccharides with different structures called isomers, so monosaccharide would be as specific as you need to be. For number 10, this is going to be a molecular formula. We have C and O, and it's inorganic. The reason this one is inorganic and not organic is that it lacks hydrogen. There's no hydrocarbon backbone for this one, so we can stop on that. 11, here we have a little bit of a clue given to you that it says phospholipid. So this one is clearly structural. There's no, on this one, there are no carboxyl groups that are exposed or present, or amino groups. It's got carbon, hydrogen, oxygen, and we can see over here that there is a phosphate group over here, so there's some phosphorus there as well. This one is organic, and it's a lipid, and it's specifically it is a phospholipid. And we know that because it contains the phosphate group and it has only 2 fatty acids attached to it. The other thing that we can say here is that at least one of those is fatty acid. I'm sorry, that at least one of the fatty acids is unsaturated. Okay, number 12. Let me zoom in here a little bit for us. Number 12, this is going to be a structural formula. We have the elements carbon, hydrogen, and oxygen present. This is going to be organic. And again, whether it's a lipid or a carbohydrate, we need to take into account. Now, when we look at this, when we count up the total number of atoms, it's in a 1 to 2 to 1 ratio. We see 7 total carbons, 14 hydrogens, and 7 oxygens. So 1 to 2 to 1, this is going to be a carbohydrate. And it's a monosaccharide because there's a pure 1 to 2 to 1 ratio. And again, you probably can't tell what kind of monosaccharide, but what you can tell is that this is an aldose sugar because the carbonyl group is at the top. So for a bonus point, I would say aldose. If you could give me that, that would be a bonus. Okay, here, structural. We've got carbon, hydrogen, oxygen, and nitrogen present. It's organic. Clues that I'm looking at here, I'm seeing, because it's got carbon, hydrogen, oxygen, and nitrogen, I know that it's got to be associated with protein. And I should remember that if I see the NCC type of backbone, that represents more than one amino acid joined together. In this case, I have actually 2 amino acids. I've got this one here and this one here. So this would be a dipeptide. All right. I can't tell for sure what kind of dipeptide it is. It's got 2 R groups here, and both of them appear to be, well, this one appears to be a polar R group because of the oxygen. This one is probably nonpolar because it's just carbon and hydrogen there. All right, next one we have, this is a structural formula. We have carbon, hydrogen, and oxygen as well. This is organic. And when we look at this, obviously you're given a clue on this problem that it's ribose. Obviously I'm not going to give you that kind of clue on your exam, but if you counted up carbon, hydrogen, and oxygen here, it's in a 1 to 2 to 1 ratio, so this is also a carbohydrate. And this is a monosaccharide. Okay, now this monosaccharide specifically relates to the nucleic acid. It's a building block. And here, this is a case where you can see specifically the ribose structure. Carbon number 2, this is where the ribose molecule is identified because it's got the oxygen there. Okay, this structure down here, this is kind of a confusing one. This is molecular. It's got carbon, hydrogen, and oxygen. It's definitely organic. Now, it's not in a 1 to 2 to 1 ratio. If you look at that, it's not in a 1 to 2 to 1 ratio. It's got lots of carbon and hydrogen, but very little oxygen. So this one is going to be a lipid. And one thing that we're going to want to notice here is that there are 3 of these long carbon chains with lots of hydrogen on them. So if there are 3 of those, and we know it's a lipid, these right here, these are probably the fatty acids. Okay, and this is probably the glycerol. So I would guess, if I was looking at this molecule, I would say that this is a triglyceride. Right? Because I've got the 3 carbon structure, which is glycerol, and I've got that 3 of those long chains of carbons, which are probably the fatty acids there. Okay, and then the final thing we're going to take a look at here, this is a structural formula. And carbon, hydrogen, and oxygen, which again tells me that I'm looking at either a carbohydrate or a lipid. It's organic. And when I count up the atoms here, it's not exactly 1 to 2 to 1, but it's going to be very close to 1 to 2 to 1. It's going to be that C12H22O11 formula. So I know that this is going to be a carbohydrate. It's awfully close to 1 to 2 to 1. And I can see that there's 2 structures joined together. So when I have 2 carbohydrate structures joined together, this is going to be a disaccharide. Okay. One additional important thing that you might note here is the bond between those 2 monosaccharides. This is called a glycosidic linkage. Okay. So I've shared with you hopefully some clues as to how you go about identifying these molecules. Really important for you to understand the types of elements that are in each of these 4 major classes of molecules, because that'll really, I think, help you to at least focus so you know which of the 4 you're looking at, and then you become more specific by looking at clues that are within the molecules. Okay? Any questions you have, please let us know in class or shoot an email to your teacher. For now, Mr. Gale signing off. I'll see you again soon.